Amino acids. Scary. So many numbers, so many letters, so many lines. You may be scared thinking, oh, I can't remember all 20 of them. But if you can remember all the lyrics to a Drake song, you definitely can remember these 20 amino acids. I believe in you. Let's get going. All amino acids are going to have a full name, a 3-letter code, and a 1-letter code. They're all going to be chiral except for glycine, and L configuration. Don't worry about wedges and dashes. All amino acids are also going to share some structural elements. They're all going to have an amino group. They're all going to have a carboxylic group. The R groups are where each amino acid is different. The R group, the carboxylate, and the amino group all are connected to the alpha carbon. There are 4 main groups of amino acids. Let's start with nonpolar. These amino acids are hydrophobic and usually found in the center of proteins. This is alanine, nothing too crazy, nothing too special about her. This is leucine, and if you look at it in kind of a roundabout way, you can kind of see an L shape, and that's how I remember it. In a similar fashion for isoleucine, I see an I shape. For proline, I, shocker to nobody, see a P, but I think it's also important to remember that the amino group there is actually part of the pentagon. For valine, I see a V. For methionine, I remember there's a methyl group connected to the sulfur there. You'll remember glycine as not having an R group and being the only non-chiral amino acid. Phenylalanine is alanine with a phenyl group slapped on. It's very important to remember, though, that it's F and not P. P is proline. Okay, tryptophan is kind of one of the less straightforward nonpolar amino acids, but you can remember the W by kind of seeing the W, or you can say it in your mind like tryptophan, and that's how I remember it. Moving on to the polar group, these amino acids are hydrophobic and found on the exterior of the protein. This is cysteine. It's going to be important when you start talking about disulfide linkages. This is serine, which is not to be confused with threonine, which is very, very similar with just one more carbon. This is glutamine. We couldn't use G because we used it for glycine, and you couldn't use GLU because you're going to use it for glutamic acid. Just remember Q, like glutamine. For asparagine, you're just going to have to really emphasize that N. Asparagine. Moving right along, we're going to start with the basic group. All of these are going to have a +1 charge at pH 7. For lysine, in my head, I just call it longine, and for the K, you're just going to have to remember that. For arginine, bring out your inner pirate and call it like arginine. Histidine is considered basic, even though technically it doesn't actually have that +1 charge at pH 7, but don't think about it too much right now. We have finally made it to the acidic group, which has that -1 charge at pH 7. This is aspartic acid, which you kind of have to pronounce in your mind as aspartic acid, which can also be called aspartate if it is not deprotonated. Glutamic acid is also called glutamate if it is still protonated. And with that, we are done. Those are the 20 amino acids. Here are my recommendations for studying. I definitely recommend this app. It's called Amino Acids Quiz. It has all the different letter codes, the full names, the structures, everything you could possibly need. Also, flashcards. You can't go wrong. If you don't live in the 1950s, you can also do a Quizlet or some other thing I haven't heard of. I definitely recommend you practice drawing them and making sure that you're actually right when you draw them. Good luck studying. Thank you so much for watching this video.